Welcome back once again to another edge thickness example. So previously, I went over this example and we calculated the minimum wall thickness between this hole and this wall. And I think now it's best to go through a slightly more complicated example. And this example is going to look like this. So I should have been a little bit smarter in the previous example. I should have made this 1 at maximum material condition, and if I wanted to have a 0 at MMC, maybe I should have made this 0. But nonetheless, this is what the new example looks like, and I've also added a second feature control frame on this datum C hole. We're going to go through all the same steps that we went through in the previous video because I think it's good to really enforce that. So step 1, we want to think about how the features need to move to achieve that minimum wall thickness. And again, the datum B wall needs to push in. We need some form error in the datum B wall. Then the datum C hole needs to push towards the datum B wall. And then the 10 millimeter hole needs to push as far away from the 21 millimeter hole as it can. So an exaggerated view or exaggerated drawing of this, step 2. And this is approximately what it would look like, and we can't see any of the deviation in the hole or any of the travel in the hole without looking at the gauges. Like I said in the previous video, we're going to do the form error early on. So step 3, we're going to look at the form error. It's still only 1 millimeter. I haven't changed this at all. And then step 4, we're going to look at the gauges. I said in the previous video that there's typically the same number of gauges as unique feature control frames, but this is one of those cases where it's not typical. And the rule breaks down when you have multiple feature control frames on one feature. So in this case, I've got the true position of the 21 millimeter hole, true position of 1 millimeter at MMC relative to AB, and then a refinement, a perpendicularity of 0 at MMC relative to A. So in this case, we need still just 2 gauges. The first gauge, of course, is the distance from the datum B wall to the axis of the virtual condition pin. And the virtual condition pin is relative to, or with respect to the true position. And then the second gauge is the 30 millimeter distance between the axes of the 2 virtual condition pins. This virtual condition pin is, of course, with respect to the true position, but this virtual condition pin is with respect to the perpendicularity. And this is why in the previous video I said that you can't just blindly assume that the virtual condition pins between 2 gauges are going to be the same, is for cases like this where you have some sort of refinement. Now step 5, let's calculate the sizes. Well, the hole, of course, all the holes we're going to be looking at are just going to be the maximum allowable size or the least material condition. So in this case, the hole is 21 millimeters plus 1 millimeter. And that's according to this size up here, which is 22 millimeters. The virtual condition pin is the 21 millimeters minus its size tolerance and then minus the allowable position, so 19 millimeters. Jumping over to gauge 2, again, least material hole, 10 millimeters plus 1 millimeter, 11 millimeters. Virtual condition pin, 10 millimeters minus 1 millimeter minus 1 millimeter of true position. It's 8 millimeters. And the hole is the same for the bottom. And then for the second virtual condition pin for the 21 millimeter hole, it's 21 millimeters minus its allowable, or minus the size, minus 1 millimeter, minus 0. So 20 millimeters is the second virtual condition pin. And now it's time for the math, which I'm going to do live for you. All right, let's begin. So I'm going to do this by superimposing the first gauge, and then once we get to the point where we'd want to switch gauges for the calculation, I'll superimpose the second gauge. Let's start with our 0. And then I like to come in and make sure we don't forget about our form error. So we said that is 1 millimeter. Now we can start the interesting math. So we know that the virtual condition pin is 60 millimeters from this wall. So let's go over here and say 60 millimeters. We want to know where the edge of this hole is. Let's go here. And we say 60 millimeters plus half of the virtual condition pin. So we just jump half the distance because we're at the axis. 19 over 2 is equal to 60 plus 19 divided by 2, 69.5. And then we can subtract the hole size to get to the other edge. So we'll go here and say 69.5 minus 22 is equal to 47.5. Now we're going to switch to the second gauge. Half the distance or half the diameter of the virtual condition pin from this wall will get us to the axis of the virtual condition pin. So 47.5 plus 20 divided by 2 should be 57.5. Now we'll jump to the other virtual condition pin, which from the drawing is 30 millimeters away. So 57.5 minus 30 is equal to 17.5. Then we will jump forward to the edge of the hole, half the diameter of the virtual condition pin. I'm just going to jog this so I've got a little bit more space. 17.5. We're doing it live. Made a mistake. This should have been 27.5. You guys thought I was going to miss that. That was a test. So 27.5 plus 8 over 2 is equal to 31.5. And then we will jump backwards the diameter of the hole to get to this edge. 31.5 minus 11 is equal to 20.5. So the minimum edge thickness is equal to 20.5 minus 1 is equal to 19.5. Hopefully that was instructive about why you need to stay really organized and really make sure you're doing the correct math, because even though it's super basic, it's easy to make a mistake. Something else, I find the more common mistake that I've had in doing practice examples from books and whatnot is either adding or subtracting when I should have been doing the other one. So that's why I find the drawings quite useful, is because I can, you've got a direction reference and you can sort of get a feel, if something doesn't feel, you get a sense if something doesn't feel right. In any case, here's a bonus question, and the only difference between this and the problem that we just worked through is that we don't have a second feature control frame controlling the perpendicularity to A on the 21 millimeter hole. And before I show you the solution, why don't you pause the video and have a crack at it yourself? I'll just give you a minute to do that. Okay, and solutions coming in 3, 2, 1. Whoops. 3, 2, 1. There we go. So the minimum edge thickness is 19 millimeters instead of what we calculated, which was 19.5. Hopefully this was all instructive, and hopefully you had a laugh at my expense making mistakes, but it happens. And if you ever notice that I've made a mistake in a video, absolutely comment to let me know. And also, if you've got any questions or problems you'd like me to go over, I don't know that I'll definitely be able to help, but I'm always willing to take a look at it. And yeah, have a good one.